Hey everyone, welcome to a chemistry podcast on periodic trend. You can make predictions about certain behavior patterns of an atom and its electrons based on the placement of the atom on the periodic table. All of the periodic trends can be understood in terms of these three basic rules. The first rule, electrons are attracted to the protons in the nucleus of an atom. Well, the closer an electron is to the nucleus, the more strongly it is attracted. And the more protons in a nucleus, the more strongly an electron is attracted to it. The second rule is that electrons are repelled by other electrons in an atom. So if other electrons are between a valence electron and the nucleus, well, the valence electron will be less attracted to the nucleus. The third rule, completed shells and to a lesser extent completed subshells are very stable. Atoms prefer to add or subtract valence electrons to create complete shells, if possible. The atoms in the left-handed side of the periodic table are metals. Metals give up electrons when forming bonds. Most of the elements in the table are metals. Nonmetals generally gain electrons when forming bonds. The metallic character of the elements decreases as you move from left to right across the periodic table. The elements in the borderline between metal and nonmetals, such as silicon and arsenic, are called metalloids. What atomic radius is the estimated distance from the nucleus of an atom to its valence electrons. Moving from left to right across a period, like lithium to neon for instance, the atomic radius decreases because from moving left to right, protons are added to the nucleus, so the valence electrons are more strongly attracted to the nucleus, so decreasing the atomic radius. From moving down a group like lithium to cesium, the atomic radius increases. From moving down a group, shells of electrons are added to the nucleus. Each shell shields the more distant shells from the nucleus, and the valence electrons get further away from the nucleus. Protons are also being added, but the shielding effect of the negatively charged electron shells cancels out the added positive charge. Cations are positively charged ions are smaller than atoms. Generally, when electrons are removed from an atom to form a cation, the outer shell is lost, making the cation smaller than the atom. Also, when electrons are removed, the electron-to-electron repulsions are reduced, allowing all of the remaining valence electrons to move closer to the nucleus. Anions, or negatively charged ions, are larger than atoms. When an electron is added to an atom, forming an anion, electron-to-electron repulsions increase, causing the valence electrons to move further apart, which increases the radius. I want you to rock me. Electrons are attracted to the nucleus of an atom, so it takes energy to remove an electron. The energy required to remove an electron from an atom is called the first ionization energy. Once an electron has been removed, the atom becomes a positive charged ion. The energy required to remove the next electron from the ion is called the second ionization energy, and so on. Moving from left to right across a period, ionization energy increases. Moving from left to right, protons are being added to the nucleus, which increases its positive charge. For this reason, the negatively charged valence electrons are more strongly attracted to the nucleus, which increases the energy required to remove them. Moving down a group, shells of electrons are added to the nucleus. Each inner shell shields the more distant shells from the nucleus, reducing the pull of the nucleus on the valence electrons and making them easier to remove. Protons are also being added, but the shielding effect of the negatively charged electron shells cancels out the added positive charge. Electronegativity refers to how strongly the nucleus of an atom attracts the electrons of other atoms in the bond. Electronegativity is affected by two factors. The first one is the smaller an atom is, the more effective its nuclear charge will be felt past its outermost energy level, and the higher its electronegativity will be. Second, the closer an element is to having a full energy shell, the more likely it is to attract the necessary electrons to complete that level. And in general, moving from left to right across a period, the electronegativity increases, and moving down a group, electronegativity decreases.